Let's do this. So where we at is Unit 2 at Statistics and Probability. Today I'll try to squeeze in discrete math on MIT. It's gonna be interesting day. Okay, representing data. This is where we at Statistics and Probability. Let's do this.
What I want to do in this video is think about all of the different ways that we can represent data. So right over here, we have a list of, and I'm just using this as one form of data, a list of student scores on, say, the last test. So Amy got 90% right, Bill got 95% right, Cam got 100% right, Efra also got 100% right, and Farah got 80% right. This is one way to show data. Remember, data is just recorded information, and it could be numeric like this. It could be quantitative, so you're recording actual numbers, or it could even be things. You could record data on how did they like the test, and they could have scored it based on I really liked it, I kind of liked it, I didn't like it. Or they might have rated it on a scale of 0 to 5, which would have been numbers, but it's numbers that are measuring people's opinions, as opposed to here we have numbers that are measuring their actual scores. So there's all different types of data, and I don't want to get into all of that. But let's just start thinking about different ways to represent this data. So this is one way. You could view this as a table where you have the name, and then you have the score. So you have your name column, and then you have your score column, and I could construct it as a table. So it clearly looks like a table like that. That's one way, one very common way of representing data, just like that. That's actually how most traditional databases record data, in tables like this. But you could also do it in other ways. So you could record it as a oftentimes called a bar graph, or sometimes a histogram. So you could put score on the vertical axis here, and then you could have your names over here. And let's see the scores. Let's see, maybe I'll make this a 50. Actually, let me just mark them off. So this is 10, 20, 30. No, that's too big. 10, 20, 30, 40, 50, 60, 70, 80, 90. So that's, and then 100. So that's 100. 1, 2, 3, 4, 5. That would be 50 right over there. And then you could go person by person. So Amy got a 90 on the exam, so the bar will go up to 90. So that is Amy. Bill got a 95, so it's going to be between 90 and 100, so it's going to be right over there. Bill got a 95, and so it would look like this. Bill. So that is Bill. And then you have Cam, who got 100 on the exam. So make sure, obviously I'm hand drawing it, so it's not as precise as if I were to do it on a computer. So this right over there, that is Cam's score. Efra got the same score as Cam. So her score is going to be, let me do that in the color, in Efra's color. That's Efra's score right now there. She also got 100. So Efra, and then finally Farah got an 80. So 60, 70, 80. So Farah got an 80. So this is Farah's score right over here. So this is another way of representing the data. And here we see it in visual form, but it has the same information. You can look up someone's name and then figure out their score. Amy scored a 90. Bill scored a 95. Cam scored 100. Efra also scored 100. Farah scored an 80. And there's even other ways you can have some of this information. In fact, sometimes you might not even know their names. And so then it would be less information, but it might just be a list of scores. The professor might say, hey, here are the 5 scores that that people got on the exam. And they would list 90, 95, 95, 100, 100, 100, and 80. Now, if it was listed if this was all of the data you got, this would be less information than the data that's in this bar graph or this histogram. and or the data that's given in this table right over here. Because here, not only do we know the scores, but we know who got what score. Here, we only know the list of scores. But there's even other ways, and this is not an exhaustive video of all of the different ways you can represent data. You could also represent data by looking at the frequency of scores. So the frequency of scores right over here. So instead of writing the people, you could write the scores. So let's see, you could say this is 80, 85, 90, 95, and 100. And then you could record the frequency that people got these scores. So how many times do you have a score of an 80? Well, Farah is the only person with a score of 80, so you put one data point there. No one got an 85. One person got a 90, so you put a data point there. One person got a 95, so you could put that data point right over there. And then two people got 100. So this is 1 and 2. Let's see, the other 100 is in this color, so I'll just do it in the color. You wouldn't necessarily have to color code it like this. So this is another way to represent, and this is, in this axis you could just view this as the number. So this tells you how many 80s there were, how many 90s there are, how many 95s, and how many hundreds. So this right over here has the same data as this list of numbers. It's just another way of looking at it. And once you have your data arranged in any of these ways, we can start to ask interesting questions. We can ask ourselves things like, well, what is the range of data? What is the range in the data? And the range is just the spread between the lowest point and the highest point. So the range in this data is going to be the difference between the highest score, and the highest score is our 100, and the lowest score, an 80. So the range is going to be the difference between the max minus the min, the maximum score minus the minimum score. So it's going to be 100 minus 80 is equal to 20. So that gives you a sense of things. It kind of gives you a sense of spread. You could also ask yourself, well, how many people scored below 100? And these are just interesting questions. Below 100. And you can actually answer that question. Well, actually, you could have answered either of these questions with any of these different ways of looking at the data. If you say how many people scored below 100, well, 1, 2, 3. How many people scored below 100? Well, 100 is up here, so it's going to be 1, 2, 3. How many people scored below 100? 1, 2, 3. How many people scored below 100? 1, 2, 3. And so any way you look at it, you would have gotten 3. And you could also ask yourself, what is the most frequent score? So most frequent. Most frequent. And once again, you could answer that question with any of these ways of representing this data. You could look at our original table and you say, look, there's only 190, 195, 180, there's 200s. So you'd say, look, there's the most frequent score is 100. You'd see that over here too. You actually have 200s. There's only one of each of the other scores. Here you also see the 200s. And here is probably the clearest if you're looking at frequency. Sometimes this might be called a frequency plot. Sometimes it's called sometimes the official, it's often called a frequency plot. And you see here the most frequent one is the one that has the most dots on it, which is 100. So anyway, that's just a very high level overview of how you can look at data and different ways to represent data. But the one thing I really want you to get from this is that these are all different ways of representing the same data. And we could probably invent other ways of doing it as well.
طيب.
What I have here is the list of ages of the students in a class. And what I want to explore in this video is different ways of representing this data and then see if we can answer questions about the data. So the first way we can think about it is as a frequency table. Frequency table. Frequency table. And what we're going to do is we're going to look at for each age, for each possible age that we've measured here, to see how many students in the class are of that age. So we could say the age is one column, and then the number of students of that age. Or we could even say the frequency. Frequency. When people say, how frequent do you do something? They're saying, how often does it happen? How often do you do that thing? Frequency. Or we could also say, actually, let me just write number. I'm always a fan of the simpler number at age, which we could also consider the frequency at that age. The frequency of students. All right. So what's the lowest age that we have here? Well, the lowest age is 5. So I'll start with 5. And how many students in the class are age 5? How frequent is the number 5? Let's see. There is 1, 2. Let me keep scanning. Looks like there's only 2 5s. So I could write a 2 here. There are 2 5s. And now let's go to 6. How many 6s are there? Let's see. There's 1 6. There's only 1 6-year-old in the class. All right. 7-year-olds. Let's see. There's 1, 2, 3, 4 7-year-olds. 4 7-year-olds. Now what about 8-year-olds? 8-year-olds, I'm going to do this in a color that I have not used yet. 8-year-olds, we have no 8-year-olds. 0 8-year-olds. And then we have 9-year-olds. Let's see. 9-year-olds, we have 1, 2, 3, 4 9-year-olds. 4 9-year-olds. 10-year-olds, what do we have? We have 1 10-year-old right over there. And then 11-year-olds. 11-year-olds, there are no 11-year-olds. And then, let me scroll up a little bit. And then finally, 12-year-olds. 12-year-olds, there are 1, 2 12-year-olds. So what we have just constructed is a frequency table. It's a frequency table. You can see for each age how many students are at that age. So it's giving you the same information as we have up here. You could take this table and construct what we have up here. You would just write down 2 5s, 1 6, 4 7s, no 8s, 4 9s, 1 10, no 11s, and 2 12s. And then you would just have this list of numbers. Now, a way to visually look at a frequency table is a dot plot. So let me draw a dot plot right over here. So a dot plot. And a dot plot, we essentially just take the same information and even think about it the same way, but we just show it visually. So in a dot plot, what we would have, actually, let me just not draw an even arrow there. We have the different age groups. So 5, 6, 7, 8, 9, 10, 11, and 12. And we have a dot to represent, or we use a dot for each student at that age. So there's 2 5-year-olds, so I'll do 2 dots. 1 and 2. There's 1 6-year-old, so that's going to be 1 dot. Right over here. There's 4 7-year-olds, so 1, 2, 3, 4 dots. There's no 8-year-olds. There's 4 9-year-olds. So 1, 2, 3, and 4. There's 1 10-year-old. So let's put a dot, 1 dot right over there for that 1 10-year-old. There's no 11-year-olds, so I'm not going to put any dots there. And then there's 2 12-year-olds. So 1 12-year-old and another 12-year-old. So there you go. We have frequency table, dot plot, list of numbers. These are all showing the same data, just in different ways. And once you have it represented in any of these ways, we can start to ask questions about it. So we could say, what is the most frequent age? Well, the most frequent age, when you look at it visually, the easiest thing might be just look at the dot plot because you see it visually. The most frequent age are the 2 highest stacks. So there's actually 7 and 9 are tied for the most frequent age. You would have also seen it here, where 7 and 9 are tied at 4. And if you just had this data, you'd have to count all of them to kind of come up with this again and say, okay, there's 4 7s, 4 9s. That's the largest number. So this is, if you're looking for what's the most frequent age, when you just visually inspect here, it probably pops out at you the fastest. But there's other questions we can ask ourselves. We can ask ourselves, what is the range? What is the range of ages in the classroom? And this is once again where maybe the dot plot is the most, it jumps out at you the most, because the range is just the maximum age in or the maximum data point minus the minimum data point. So what's the maximum age here? Well, the maximum age here, we see it from the dot plot, is 12. And the minimum age here, you see, is 5. So there's a range of 7. The difference between the maximum and the minimum is 7. But you could have also done that over here. You could say, hey, the maximum age here is 12. Minimum age here is 5. And so subtract from 5. You find the difference between 12 and 5, which is 7. Here, you would have not had to do it. You still could have done it. You could say, okay, what's the lowest? Let's see, look at 5. Are there any 4s here? Nope, there's no 4s. So 5 is the minimum age. And what's the largest? Is it 7? No. Is it 9? 9? No, 10? Oh, 12. 12. Are there any 13s? No. 12 is the maximum. So you say 12 minus 5 is 7 to get the range. But then we could ask ourselves other questions. We could say, how many older than 9 is a question we could ask ourselves. And then if we were to look at the dot plot, we say, okay, this is 9, and we care about how many are older than 9. So that would be this 1, 2, and 3. Or you could look over here, how many are older than 9? Well, it's the one person who's 10, and then the 2 who are 12. So there are 3. And over here, if you said how many are older than 9, well, then you would just have to go through the list and say, okay, no. Okay, here, 1, 2, 3, and then not that person right over there. So hopefully this is just an appreciation for yet another 2 ways of looking at data: frequency tables and dot plots.
Five, 1, 8, 3, and then I got 5 again, right? 7, 2, 6, 0. Some 4. استدعي 54 56 53 54 56 55 2 30 53 1 55 1 56 2 52 0. Number of members. Number of children. 1. Only 1. 2. Only 1. 3. I got 2. 4. I get 1. 5. I got 3. Okay. create dot plots. Lena is training. Okay. Number of haircuts, number of shifts. 15, I got 3. 16, I got 2. 17, I got 2. 18, I got 1. 2, 5, 2, 4, got 1. 7, I got 2. And then 6, 6, I just got 1. 6. No, no, no. Okay. Frequency table shows the number of Joy's pictures that have been published in each of the local magazines. Number of pictures, number of magazines. How many magazines published 2 or more of Joey's pictures? 2 or more. I got 3, 2, 1. That's 6. How many days had a high temperature of at least 16? So I get 16, 2, 4, 6, 7. 7. I got 7. The row shows the daily high temperature. So this is daily temperature. Number of cavities. What is the most frequent number of chocolate chips in in cookie in a cookie? This one. 1, 2, 3, 4, 5. Frequent. 4. Number of chocolates. 4. Oh my God, we gotta go. Following dot plot. What was the fewest goals that Hank scored in a season? Number of goals. Wait. Number of goals 33, 44, 45, 46, 47. What was the fewest goals that Hank scored in a season? I get 40, 43, 43 and 47, or 46. He scored. He scored, but here he got falling down. Lacquer's scoring in each season. Each dot represents a different season. Different season. So I'd say 46 and 47. Do this again. Do it again so it doesn't bother me again. Over and over. Do we still have review? I think 3 out of 4 correct. Okay, frequency table review. I think we'll take this tomorrow, am I correct? We got dot plots and frequency tables are nice ways to organize and display data. To see how they work, we'll need some data. Every 4 years, soccer teams from around the world compete in the World Cup. The following list shows the number of goals scored in the championship game of each World Cup from 1930 to 2014. That is it. That is interesting, but it's too disorganized. Let's organize it into a frequency table and also a data. Shootouts, and we are not counting those goals. These matches ended. These one. These matches ended in penalty kick shoots outs, and we are not counting those goals. The well, today's we finished. That's it for me for the statistics and probability section. I mean video today. We'll continue tomorrow here in creating histogram.